Let's talk about Ad Click Aggregator system. So what an Ad Click Aggregator system is, like, it consists of these four components, that is collection, tracking, data handling and integration. So if we talk about collection, this platform gathers and unifies click data from various sources, let it be ad networks or devices or users and so on, which leads towards tracking of data. And what tracking is, it tracks user interactions across multiple channels, consolidating click data for analysis by other processing or aggregating them and extracting some really meaningful insights. Now coming towards data handling, the platform ensures precise attribution of clicks in order to prevent spam. Let's consider a scenario where a user, if clicked multiple times on the same ad in the same instance of time, it should be counted as only one click to get accurate analysis rather than unnecessary redundancy. Now all these data integrates with analytics tools for advertisers to have a view on comprehensive insights. That is integration for us. So that's all about Ad Click Aggregator system. Now let's move ahead towards what all requirements should we consider for designing this system. So talking about functional requirements first, we are considering two functional requirements as of now. The first one is a user, when clicks on the ad, it gets redirected to the ad page. And the second one is advertisers can analyze the insights. Insights as in how many users have viewed their advertisements, or from what locations people are viewing the advertisement, or what percentage of male population or what percentage of female population is viewing the advertisement, so they can target such audience and so on. The list goes on and on. So this is the second requirement for advertisers to analyze their insights. So these are the two functional requirements. Now going forwards toward non-functional requirements, we are considering four as of now. The first one is to prevent fraudulent clicks, which we earlier discussed in data handling. The second one is there could be 5 to 10 million ads at any given point of time. So we should consider this scenario as well. The third one is peak time can have 10,000 clicks per second. So we should consider this amount of scalability in our system. The fourth one is real-time analysis. For this video going further, we'll see the HLD for both batch processing, and we'll derive a real-time system from that batch processing HLD. So we'll be seeing both of this further. So let's now move ahead towards the high-level design for the same. Let us start with the high-level designing of this system. So as per our functional requirements, we had two requirements. One was user, when clicks on the ad, should be redirected to the ads page, and advertiser can analyze those clicked data. So let us draw two entities out here first. Let's say user device, and the other is advertiser, right? So this user device would be getting ads. So where will it get ads from? So it will be getting ads somewhere from some database. We are not much concerned about it, but let us state it out here. Like, let's say there is some advertise DB from where we are getting advertisement related data. Let's say it can contain ad ID or any information regarding to the ad, or the redirect URL, and some other metadata as well. So these could be the information from this advertise DB, which will be receiving in user device through service. Let's say there could be an advertising service. So these advertising service would process this data and get ads to our user device. So user will get this ads, and this ads, on clicking, the click data would be stored somewhere. So where it will be stored? So there would be a database, let's say clicked data database, click data DB, where all the clicked data which this user clicks would be stored here, right? click data DB. Okay, so what all things would be stored here, like possibly it could be a click ID, let's say primary ID for this for a particular event of click. You can have a user ID, this is mandatory, which user has clicked through it. You can have the ad ID, even this is mandatory to perform analysis over a particular ad. And there could be timestamp, there could be let's say location information and anything, and other metadata as well. So there could be multiple information, such informations of the ad and the user in this click data DB. So this will not directly go to the database, so let's add a service here as well. So there would be a service which would be Ad Click Processing Service. Now what will this service do? This will do two main operations. One is to redirect, it redirects to the URL, and the second one is it would perform further processing. Right, so these are the two things which this ad click processing service would perform. Now advertiser want to analyze this data, so there would be a service for advertiser as well, that is, let's say analytics service. Now through this analytics service, advertiser can view the aggregated data, or let's say the information regarding this data. And what will this do? This will send some queries, definitely send queries to get let's say some click metrics or aggregates, right? So this would send queries to get some click metrics or aggregates which advertiser can have insights of. So what kind of queries this could be? Let me give you an example of one query. Let me write that query. So this query would be writing to get total clicks and total unique users. So let me write select for total clicks. We will get a count of total clicks and will get count of, let's say, distinct user IDs, as let's say total unique users from our table, that is click data, let's say click data for now, and where the condition would be the ad ID should be 15 as of now. I'm considering it can be any. So for a particular ad we want this total clicks and total unique users, and say timestamp which is between, let's say, some start time and some end time. So this is the query. So we are fetching this total clicks and total unique users between this start time and end time for this particular ad ID, which is 15, right? So this is one possible query. There could be many such queries. Now assume that the start time and end time is of like this timestamp is between the start time and end time, which causes 1 hour, right? So we are fetching this records for 1 hour. So as per our non-functional requirements, we have seen that in peak hours there could be 10,000 click per second. So imagine the amount of data in 1 hour. Then if we consider this start time and end time for a particular day or 1 week, or let's say we expand it to 1 month or even 1 year, then consider the amount of data, because even we are considering for 10 to 15 millions of the ads at a given point of time. So imagine the number of data and imagine the latency. the time it will take to process these queries. So this would be a bit difficult, right? So we can't directly just process with our relational database. Even if we add indexes to process such high amount of data and process these queries would be a bit challenging. So what can we do now? Like instead of storing data in relational database, can we store this kind of data in a NoSQL database such as, let's say, Cassandra or DynamoDB? So why should we store it in Cassandra or DynamoDB? Like our application is a write heavy application for the clicks. So it can handle heavy write operations. It can even handle large volume of semi-structured and unstructured data. However, relational database can only handle structured data. So this can handle both semi-structured and unstructured data. It uses distributed architecture and is designed for high availability and fault tolerance. So we can use this Cassandra or DynamoDB. If you want some ease in management and some managed resources with an integration with AWS, then DynamoDB would be a good choice. And if you can manage resources on your own, Cassandra would be a good choice, as Cassandra is cost effective as well. DynamoDB may cost you a bit. So yeah, you can use either of them. I prefer Cassandra because it's cost effective. So moving further, to process this data, like through this analysis service, we want to process this data and give it to advertiser. So for that, let us do one thing. Let us pre-aggregate this data and store it somewhere. So let us pre-aggregate this data, and where will we store it? Let's say we will store it somewhere here in, let's say, OLAP, or you can say some data warehouse as well. Warehouse, let me connect this here. Okay, also we would need an Apache Spark. Like how will we transform this raw data into this aggregated data? So this OLAP or data warehouse we are using because we can store aggregates. Like we would process all the data from here and we'll store it out here. So whenever this advertiser want to view this analytics data, he will directly get it from this data warehouse or this OLAP service. So he don't need to execute the queries each and every time. So something between this should be Apache Spark. So let me keep an Apache Spark here. So Apache Spark would perform some extract, transfer, load kind of thing, some ETL here. So it will fetch data from this DB and would process the data and store it in here in data warehouse or OLAP. So data warehouse can be any Amazon Redshift or Google BigQuery or Snowflake, or if you want to use OLAP, both can be used. Like if you want some multi-dimensional analysis and multi-dimensional queries, then OLAP is a good choice. And for some for the querying of heavy data and something, you can use data warehouse like this BigQuery, Snowflake or Redshift. So this is how it will look. And for this, consider this as a set of code which would perform this extract, transform and load from this raw data to this aggregated data. So this will be performed when we apply some scheduler. Let's say we are applying a scheduler here. Here's a scheduler. So it's a kind of a cron job. like what will it do? Like let's say after every 5 minutes. So after every 5 minutes, this would run Apache Spark, which would take all the raw data and perform the querying of the aggregates and update this OLAP or data warehouse, through which the advertiser can get the required analytics information. So this was batch processing. Now it is still not real time. Like let's say if we are scheduling it for 5 minutes, then after every 5 minutes, in between those 5 minutes, the advertiser can't see the updated value. So this is not real time. So how can we make it more real time? So let us move forward towards it. For that, let us remove this database, Apache Spark, and the scheduler as well. So what it will do? So from this Ad Click processing service, our data will directly come under a messaging queue. So let's say here is a messaging queue. So what message queue would we use? Let's use Kafka. Let's say it's message queue. So what will it do? What is the purpose of using this message queue here? So it ensures that data is buffered and delivered to the processing layer in a fault tolerant manner. So how does it act? Like it acts like let's say a message broker. So we were getting requests, like all the data, we were getting this request all together in the database from the service. So what will this message queue do is it acts as a broker. It stores data which are either partitioned or let's say sharded and replicated across a cluster. It transports data being a data pipeline. So there would be messages in this queue. Not all the messages at a single time come to the database. So this will act as a queue, and this stream would now further go to a stream processor. Let's say we have a stream processor, Kafka streams. So what will it do? So all the messages from this stream which we get will be processed out here. So all this means data, the information from this processing service which comes in this queue would one by one get processed in Kafka streams. So let's say a stream processor. Yes. And this is a stream processor. And from this stream processor, the data would be then aggregated and processed in our data warehouse. This would be stored here. So in spite of those database and Apache Spark, so this would give us a real-time experience. All the data, whenever the data is being clicked, it comes in the message queue, gets streamed here in get processed here in Kafka streams, being a stream processor, and would be stored here in OLAP or data warehouse. So what Kafka streams actually does, it performs real-time processing such as filtering, transformation, and aggregation. And this layer calculates metrics like let's say total clicks, unique users, click-through rate, and so on. So this is the job of Kafka stream. So this may get us a real-time experience. Now comes the thing that we were talking earlier, that how to prevent the fraudulent clicks. So how to prevent fraudulent clicks is we can do one thing, like we can add one more key here. Let's say instance ID. So what is this instance ID? So it happens that when you're watching an let's assume a scenario where you are watching ads in YouTube. The ad which you are getting at that particular point of time is of that instance ID. It is of instance ID 1, let's say, and the same ad you will be watching after, let's say, half an hour. So that would be some another, like the same ad with a new instance ID. So that count must be calculated, but this count at the same particular moment for the same instance ID shouldn't be considered as multiple counts, but should be considered as just one count. So based on this instance ID, when this information gets passed on towards the click, so this ad click processing service would be having this instance ID. Let's say a user is clicking on an ad with an ad ID 123 and an instance ID 15. So this is an ad and instance ID. So if a user, this particular user, clicks this particular ad with the same instance ID, then the count shouldn't be calculated. But if the same user, the same ad and the same and a different instance ID is being clicked, then that should be considered. So this is how we can prevent multiple instances, like the fraudulent multiple clicks. So yeah, that's it.